Chapter 4.4, the fundamental theorem of calculus. Day 4, the net change theorem. Now the net change theorem, very similar to the second fundamental theorem of calculus. If you take a look at it, we got from a to b, f prime of x dx equals f of b minus f of a. Very similar to the second fundamental theorem and the fundamental theorem. Basically what it's saying is we have a rate, and we're going to evaluate the change in the rate. We're going to evaluate the area underneath it. It's going to be how much is changed in that quantity. We have a rate and we're evaluating the change from A to B. We're finding the area. To find the change, evaluate the definite integral from A to B. That'll tell you how much it changed. So if we got a certain distance we're traveling and we know our velocity, this is our velocity function. We want to know how far we traveled. We find the area. Well, our y is our velocity, and velocity is change in y over change in x. We're left with our change. All right, so let's use the net change theorem. A chemical flows into a storage tank at a rate of 180 plus 3t liters per minute. So our rate, dV dt, is 180 plus 3t. Remember, that's just the way of saying v prime, where t is between 0 and 60. Find the amount of the chemical that flows into the tank during the first 20 minutes. Using the net change theorem, A and B are 0 and 20. Our rate is v prime. A and B are 0 and 20. Our rate is v prime. So we can find the net change by just taking the antiderivative of our rate from 0 to 20. So our net change from 0 to 20, because they just want to know the first 20 minutes, is 180 plus 3t with respect to t. So we'll take our antiderivative, 180t, plus 3 halves t squared from 0 to 20. And there we got 180 times 20 plus 3 halves of 20 squared minus, if I plug in 0, everything becomes 0. All right, 180 times 20 is 3,600 plus 2 and 4 reduced to 200 times 3 is 600. So that's 4,200 liters. So the net change in 20 minutes, there are an additional 4,200 liters of whatever, that chemical, in the storage tank. All right, a particle is moving along a line so that its velocity is given by v. What is the displacement? Displacement is another name for change in position. What is the displacement on the interval from 1 to 5? Well, if you want to find change, what you do is you evaluate the integral from 1 to 5 of the rate, and our rate is velocity. T to the third minus 10t squared plus 29t minus 20 with respect to t. All right, this looks like a good calculator problem. So we'll break out the TI-84 or whatever you have. And we will do the antiderivative use the Math 9 feature. Right? The antiderivative from 1 to 5 of t cubed minus 10t squared, and I'm changing it to x, obviously, plus 29x minus 20 with respect to x. So the net change is 32/3, or 10.667. Now, how is that different than the total distance traveled? Right? Displacement is just a change. How do we get that different from total distance? Well, if we take a look, we have a particle traveling on a line. The particle could do this. Be there, then here, then here. It could go back and forth. And here, if we look, the net change is actually quite small. The net change is just this distance right here. But the traveling this particle did, it went here, 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 here. That particle did quite a lot of travel. That particle made a lot of forwards and a lot of backwards motions. All right? We need to find a way to counteract the forwards and the backwards. And what we do to counteract the forwards and the backwards, how do you get rid of negatives from a function? We're going to use absolute values. So to find the total distance traveled, we ignore the negative velocities. And we do that with absolute values. So we're going to evaluate the antiderivative of the absolute value of t cubed minus 10t squared plus 29t minus 20 with respect to t from 1 to 5. So it's the same idea. We're doing the antiderivative of the rate, but here we're using the absolute value to negate or override the backwards-forward nature of the fact that the velocity could be negative. So it's the same thing. We just need to insert an absolute value. Let's see if I can insert an absolute value here. All right, I'll put my cursor there. I'll do second insert, math, number, absolute value is the first choice. And no, it's not letting me. So I'll just clear everything and start over. Math 9, same limits, 1 to 5. Here I want the absolute value, so go to math, number, absolute value, type in my function, x to the third minus 10 x squared plus 29x minus 20. Get out of the absolute value with respect to x, and I will see in this case it's 11.883 or 71/6. Remember, the only difference is now we have absolute value to get rid of that particle going backwards and forwards and going overlapping on itself. All right. So in review, the definite integral is an accumulation of rectangles and reflects the change in a function, or better put, the change in a rate. All right? And if there's negative change, you want to find total distance, you're going to do absolute value.